I'm Gaylon Campbell. I'm a senior research scientist here at Meter Group. Today we'll be talking about how to measure and understand thermal properties of materials. A meter makes sensors for monitoring above and below ground environment, and they're used all over the world. The ones for measuring thermal properties have provided some of the most varied and interesting experiences of anything we sell. I want to talk about our instruments for measuring thermal properties today and some of those interesting applications. Here's a sampling of some of the things that we've helped people with. Start with medical applications. The normal functioning of and the treatment of various organs and tissues in the human body are impacted by the thermal properties. Researchers have purchased our instruments to determine those thermal properties. Now, for the second application, nanoparticles alter the thermal properties of fluids into which they're put. Our instruments have been used to measure the performance of those fluids. And the third, the heat transfer properties of insulating materials, and sometimes even mattresses, have to be known to determine their suitability for a given application. And the fourth, electrical power cables are increasingly put underground rather than above. As electricity flows through the cables, they heat up. Thermal properties of soils and other fill materials have to be known in order to predict how much the cables will heat. For the fifth, obviously heat transfer is important in cooking and sterilizing of foods. On small scales, the cooking project, there you can determine properties that are appropriate by trial and error. But for industrial processes, thermal properties have to be measured and known to do the job correctly. For the sixth, the same is true of oils and coolants. To know how they'll perform in a given application, you need to measure the thermal properties, calculate the heat storage and transfer. And in the seventh one, thermal greases and heat sink compounds that are used in electronics and other equipment. You need to know what their thermal properties are to determine that the equipment won't overheat. And measurements provide a way to compare those and see which is best for a given application. Now, one of the most enjoyable projects that was one that we undertook about 20 years ago when the Jet Propulsion Lab asked us to make a thermal properties sensor for the Phoenix Scout mission to Mars. The lander shown on the left here, our probe was attached to the scoop that's shown on the right. There are 4 needles. Those were inserted into the Martian regolith to make the measurements. The initials TECP stands for Thermal and Electrical Conductivity Probe. The purpose of the probe was to measure the thermal and electrical properties of the Martian surface and to infer liquid content if there was any, and there wasn't, ice content, and pore size distribution.